Let's start with AUTOSAR Adaptive. Dr. Marcel Wille, welcome this morning from Volkswagen. You arrived here yesterday from Wolfsburg. Dr. Wille studied information technology at the Clausthal Technical University, and then he took his doctorate on communication networks in the automobile. Dr. Wille has been working with Volkswagen since 2008, was in charge of the launch of FlexRay at Volkswagen, made sure that FlexRay is also part and parcel of Volkswagen. And then he represents Volkswagen on different AUTOSAR committees, and AUTOSAR has been introduced at Volkswagen for a number of years, and now the next step is AUTOSAR Adaptive. And I think it's fascinating that what with e-mobility, Volkswagen is actually putting his foot down there. I'm interested to see to listen to what this means for the interior. How will the EE infrastructure actually change? The title actually points to it. Volkswagen goes adaptive. Looking forward to your presentation, Dr. Wille. The floor is to you. Yes, thanks very much for the kind words of introduction. I'm obviously really pleased to be here to talk to you about where Volkswagen is going and how we are planning to use adaptive AUTOSAR in the future. Now, yesterday, while traveling here, I thought, how do I start off? And then I saw on my agenda that Simon Fürst was speaking before me, and I thought that was perfect. He's going to give an overview of adaptive AUTOSAR, and I can build on that. And now last night, unfortunately, I heard that Mr. Fürst has held his presentation yesterday already. But I do hope that many of you will have heard his presentation and have been given some insights and the motivation of adaptive AUTOSAR. Today, I'm going to talk to you a little bit about how we are using or intending to use adaptive AUTOSAR as our software framework for the new e-vehicle platform. To start off with, I shall mention why it is that we have a new strategy, a new approach, why we need a new approach, what are the main drivers behind it. This is not so very much about the motivation of adaptive AUTOSAR. For us, this basically is just the way of getting to where we want to get. Then I'm going to talk to you about how we at Volkswagen want to tackle this change, what are the challenges involved, and then in the third step I want to go a little deeper into the into individual architectural elements of the concept. Adaptive AUTOSAR, the title points to it. Adaptive AUTOSAR plays a very important role in this context, and what we will need in what time, I'll talk about that when I talk about the roadmap of adaptive AUTOSAR, and I'll give you a conclusion in the end. Okay, let's start. Digital and connected. In addition to a highly automated driving, these are the buzzwords which are the main drivers in the automotive industry. If I look at my smartphone here, I can always, at any time and everywhere, read my emails, I can read the latest messages, I can listen to my favorite music, I know what my friends are doing, I know what the weather's like in Rio de Janeiro. From everywhere in the world, I can actually monitor my home. I can actually switch off or on my stove at home when I'm on the road. So if there's some functional or feature that I don't have, I just download the corresponding app. And in this way of thinking as we have it today, a vehicle is more or less still isolated from this digital world. Obviously, I can link up my smartphone to the car, but that's the end of it so far. That's the end of what I can imagine. And the approach where we want to go, this new way of thinking, this is where the car is an integrated part and parcel of this digital world. So, for example, if I have a functionality or a feature that I need, I can just download it. Also maybe only for a certain period of time. For example, if I want to go abroad on holiday, Then also I want to know what the prices of petrol are and what the traffic signs are like abroad. Or I want to get adaptive cruise control for 2 weeks that can use in the other country. The vehicle as such always knows where it is. It knows where the next free parking space is. It can park automatically in my garage at home because it knows the way. It knows when I have to go to work, and it knows the shortest way to get there. And it knows when the best time has arrived to actually recharge its battery. I, as a customer, do communicate with my car. I know which function and features are available on board. I know what I've maybe installed myself, and I still have the opportunity for my function and features to be available to me in the latest version, in the latest release. That is to say, we do not just have the latest information available, but also the latest functions, features, the latest apps, which means we are up to date. And this is, as far as I can see, this is where the digital world stands, what the digital world stands for, for innovation and to being up to date. The vehicle keeps developing and evolving to become a smartphone on wheels. And this smart vehicle is always online, is always connected, and is improved permanently by way of updates and upgrades. One thing is clear in this place as well. Our approaches so far won't help us here. They won't get us anywhere. With the way of thinking that when the SOP has arrived, all the functions are in place, that we are thinking in terms of ECUs, that we stick to our security approaches that we have had so far. We've heard about this morning. That's not enough. There's a lot of work in store for us. And if we just look at our building blocks, our tool cases that we have at Volkswagen, we have our current MQB, which is the modular transverse matrix. And then we have a new MEB, which is the modular electric matrix. And if we look at this more closely, you see the input factors, input variables are not so very much different. In MQB, we have difference from drivetrain, comfort, driver assist system, infotainment, and it'll be similar in an MEB. In addition, then we have automated driving that will come to it, that will come into it, and digitization. So here, that's similar. But if you look at the design criteria below it, then there is a major difference. In an MQB, we have scalability as the important factor across different classes of vehicles, across different equipment variations, so that from an A to C segment, we can actually use one toolbox. For the MEB, the focus will be on update capability and upgrade capability, and this has fundamental implications for the EE architecture in the end, and we'll take a closer look at this on the next chart. In our MQB, we have a central gateway architecture, which is excellently suited for scalability. I've got the function and features sitting on distributed ECUs. Depending on the variety or class of vehicle, I can add ECUs or can leave ECUs out. So, in this case, scalability is excellent. But if I have functions and features which are distributed across different ECUs, different domains, then I have the problem that they need to communicate intensively with each other, and then very quickly the communication medium will become the limiting factor. The next step then, and many of you know this, would be a domain architecture. So I have powerful domain controller and domain computers, domain ECUs, and I move functions from the individual ECUs into the domain computers. So I can resolve to a certain thing the distributed functionality. I'll get more flexible, but I still have the problem that if I want to have functionalities that I want to implement across the different domains, I have to go beyond the domain controllers. And if I want to scale it, then of course I have to have the domain controllers involved as well. Question is now what with an MEB, the modular electric matrix? Now we'll take it one step further there, and this is meant to be shown by the next chart. Our approach of a centralized functional architecture, where as a matter of principle we make a distinction between a sensor actuator level and a computing level, here separated by way of the red interrupted line, and on the sensor actuator level we have simply deeply embedded ECUs in the future as well, with as little intelligence as possible. So just sensors and actuators to be controlled. But then on the other level, we have high-powered in-car application servers, or ICAS. Here, in the future, this will be where the intelligence will be, the vehicle function and features will be. We've always compared this with the human brain, where we said, okay, we have a brain stem, where we have our reflexes, and we are transferring this to the sensor actuator level. We have reflexes for airbag tripping, for things like that. Based on this, we have the small brain in that deals with functions that I need for all sorts of other things, and this would be our basic services here. And these are required by a number of customer functions. For example, environmental map, or or a calculation of what's the position and in which direction is the car moving. That's an elemental part and parcel of many driver assist systems, a basic function there. And on top of this, we have the large brain where the further development takes place, where we are learning new things, where we can add new things. And this would be the level of applications here, and not just in our internal vehicle computers, but also in the cloud. Why this approach? Now today, value added is still mostly within one domain. In the future, I was pointing at it before, value added will be happening across different domains. That's to say, from these ECUs, we are taking functional parts, moving them into the in-car application servers, into this computer level. And one of the most important criteria of whether a functional parts will go there or not is whether it's updatable and upgradable. So we are moving this up one level. And by way of this approach, we get a strict uncoupling from the sensor actuator level and the customer and the customized and the car functions and features as such. There's better integration of the overall system. By way of the basic services on top, we have a more efficient and fast development of customer functions and features that we can do a lot better. And on this computing level, we'll bank on service-oriented communication. And this service-oriented communication, service-oriented architecture, from my point of view, is key, one of the most key for digitalization to be pushed on board a vehicle in order to get where we want to get. So the complexity can be reduced, system complexity can be reduced, will become capable of upgrades and updates, and we can reuse functional parts and features, but we can mutate them as well. In order to be able to do this, we have to go into the functions in addition to the basic software, into the functional architectures and the functional models. So we have to retailor the functions, break it down to single nuclear components, which must be as independent as possible from each other. And this is what we want to achieve by way of the computing level that was pointing to before. On this level, we want to use strictly dynamic bindings of services that we can find by way of a service discovery, whose addresses and information are stored in the service registry. we will have a strict uncoupling of the sensor actuator level, and in this way from of the signal-oriented communication from the service-oriented world proper. We will, when it comes to the modeling of our functions, try as much as possible to base this on the REST principle, representational state transfer. REST means fewer, simpler methods and interfaces, and statelessness, which will be necessary for individual functional parts to be able to be updated. And in this context, what's also very important is compatibility of interfaces. I have to make myself capable, as a matter of fact, to have a server or a client to be able to be updated without all the other components have to be updated as well. And what with this compatibility, I've got one chart here. In this, in order to make to enable continuous updates and upgrades, we need this compatibility in two directions. Forward compatibility is one thing. So if we assume that by way of an initial version we have a sender and a receiver, or a server and a client, with an interface, a service interface in the version of 1.0, and now I want to update my sender, that is to say, in this interface I add new elements. This interface can do more now, and the server can do more now. Then the receiver will have to be able to handle this by way of these additional elements simply being ignored. This would be forward compatibility. On the other hand, we have to have backward compatibility. That is to say, in this case, I want to update my receiver, my client. The client can do more now, has now an interface, a service interface in the version of 1.5, but it can also handle the fact that it sits on a vehicle with an ECU that is controlled by an older server. So it can ignore new functions that are not required and that it doesn't need. And we want to achieve that situation by way of using this REST principle, which comes from the world of the internet and the web services world, where we're using this REST principle together with two protocols. The one is going to be SUMIP, and the other one is PHY. Now SUMIP, this already exists in the AUTOSAR standard. We'll need a few extensions in order to be able to do what we want to do. And for example, a tag length value mechanism, that is to say, in every place in my interface, I can add elements or remove elements from it. And then we'll use PHY, means Volkswagen Infotainment Web Service Interface, comes from the infotainment field, but can be used in other domains as well, based on the JSON format, and is going to be available as the W3C standard. Another important architectural element will be the so-called communication server, which means to say it is the component which, when it comes to the sensor actor level, let's just say the signal-oriented world, separates it from the other world, from the service-oriented world. And this communication server, on the one hand, will receive signals, bus signals, from the sensor actuator levels, from the embedded ECUs at the bottom of the picture, and makes them available as service interfaces to the computing level. So if we have legacy partitions, it's also capable of passing on this information with no problem. On the other hand, what it can also do, this server, it can pass on service calls on this level, pass them on to the sensor actuator level. Okay, all these concepts we want to and we will equip with adaptive AUTOSAR, or implement them with adaptive AUTOSAR. And unfortunately, I didn't see Mr. First's presentation yesterday. He gave us an overview of it, so let's be brief here. Adaptive AUTOSAR is based on a POSIX operating system, maybe a Linux, QMX, VxWorks, Integrity, plus some functional clusters, diagnostics, communication, security, safety comes in. All of this is based on a high-performing hardware, maybe based on a machine, a virtual machines, or several virtual machines. And from my point of view, the most important item here is this dark blue box here, this ARA. So the AUTOSAR runtime environment for adaptive applications. In the final analysis, that's the standardized interfaces of the OS and the functional clusters. This is meant to make it possible for us, for basic services and functionalities, to be independent from an ICAS and from a certain operation, and from a special operational system. So this is based on our basic functionality. It's the small brain, basically, in our computer, which makes the basic functionalities available to the applications. And in this way, in conjunction with the communication server, makes a further abstraction of the sensor actuator level possible. And on top of this, we have the so-called Volkswagen API public, which is meant a link to the outside world, a simple programming interface for app developers, say. In addition to the basic software proper and the framework, what's also important is that we have the adaptive AUTOSAR with common methods, common development methods and exchange formats, and that we have common update mechanisms and communication protocols in the standards. Let's take a look at the roadmap. Together with other partners, we developed a step-by-step plan for the individual steps that we think that functional improvements should be taking place in order on the AUTOSAR level, for us on the adaptive AUTOSAR level, to be able for us to be able to use them in our system. We actually assigned them to the different AUTOSAR releases. It's important in this context that this is not a roadmap of the AUTOSAR partnership. It's our own roadmap, but it'll overlap in many areas with the adaptive AUTOSAR roadmap. In stage number one, step number one, that will be a basic scope where many of the initial features and functions will be able to be started, and we'll do this with the release in the March 2017 with the adaptive AUTOSAR 2017 of adaptive AUTOSAR. We'll get it then. And then, of course, support for the POSIX operating system. We've got the issue of execution management, the starting and the ending of application. The restart, user management is very important. Then we have the communication middleware in the first step with Ethernet and some IP. We do hope that when it comes to memory management, we'll be able to get this in this release with simple file system access mechanisms, key value mechanisms, etc. We'll have basic diagnostics protocols that we'll need there, UDS. We'll have a log and trace function that we need. And we'll also need in the first, and we'll have to make the first steps with respect to methodology and templates. How do I actually describe this? What's the description of an application like, etc. And what's very important also is here this implementation of signal-oriented communication to service-oriented communication. How can we actually manage this mapping? In a second step then, we'll have additional functionalities and features with respect to safety, and a first step with respect to software update and configuration, and in the third step then security, another step then with respect to software update and configuration. And in particular when it comes to security, what we see here is that this has a major influence, a major impact on this first step. And this is why for adaptive AUTOSAR, there will be a new feature team of security very shortly, which will look at these new concepts that we are developing, and that will make sure that we are not blocking our way in the future by way of doing the wrong things now. And then we'll try and get a Volkswagen API, a vehicle API I was talking about before, and then we'll have more general functions and features available to one uniform interface, redundancy mechanisms, hardware acceleration, further language bindings in AUTOSAR, etc. All of this will come in. This is our version of how adaptive AUTOSAR should evolve, and this is why, and that brings me to my conclusion, this is why we as Volkswagen are working together with Vector on the on pushing the standardization of adaptive AUTOSAR, so that in the end we can actually use adaptive AUTOSAR in our ICAS controllers. And these in-car applications server with adaptive AUTOSAR and software framework will become the core elements of our central functional architecture. And in this central functional architecture, the focus will be on update capability and upgrade capability in order to make it possible for the vehicle to move into the digital world of the future. Thank you very much. Fascinating, Dr. Wille. Thank you very, very much. That was some deep insight in what's in store at Volkswagen, and not just with respect to Volkswagen, but that applies to the entire automotive world. We heard a few things yesterday, but you are making it very practical and hands-on here. Now, if you look at the timeline, all of this will not be happening slowly, but there's a lot of pressure behind it. We know this. We're used to this in the automotive world. Well, we also got the challenge that in parallel proprietary solutions are being developed. So we have to be fast with adaptive AUTOSAR, and this was one of the reasons why we were saying, okay, let's not conclude the entire standard in the first release, but let's start with the basic scope with our first release and bring that out first. We'll need agility on many, many levels in the future in order to get this parallel development into place and cope with it. It'll be definitely not an evolution, but a revolution. I got a question via WhatsApp that I want to use as a start-off with question. This is a more general question. I don't know whether you're the right person to answer this. The question is whether the automated driving will be limited to the MEB platform, that's to say the electrical vehicle, or whether automated driving will also be used for the old combustion engine cars. Well, MEB will be the first step, the electrical ones, but I'm quite sure that it will be transferred to the combustion engine cars as well. And we'll have to see what the architecture will be. Yes, that will remain to be seen. Question to the floor. Any questions from the auditorium to be addressed to Dr. Wille? I'm a little bit surprised. Dr. Beck has a question there. Beck of Vector. Highly interesting. With the transition, signal to service orientation, I see this as a tough Hercules-like job. Can you say a few words about this? Because this does not touch upon know-how areas, but also on the organization structures of the organization. Yes, here as well, we are in the process of reorganization, restructuring ourselves with respect to this new digital world, with respect to this service-oriented communication. We'll focus a lot more on software and protocols, security naturally also. Apart from this, I'm quite convinced that we should avoid a situation where the signal-oriented world, as we have it today, where everything is hardwired, as it were, to be pushed into an adaptive platform. So this is why we have the approach of a strict separation by way of this communication server. And at the end of the day, it'll be a mapping process of bus signals to service interfaces. How this is going to be done, how smart this is going to happen, that's the question that remains to be seen. Yes, this is quite clear as a matter of principle. What I have a question for is that the OEM will have to take a lot more in terms of responsibility. I'm now the owner of this function. The OEM will have to say more so than this was the case in the signal-oriented world, where we said, okay, this component is supplied by Bosch or Continental, and they'll do their job properly. Is that a major step for you? Yes, it'll go very much in the way that we have our own software developments, or we'll have software vendors of a tier one to integrate it. Some parts we will integrate ourselves. As you can imagine, we have a big computer as my PC today with an operating system, and I can all install my own applications. That's most certainly an objective, a goal that we want to reach at some stage, but it will not be possible to do this in the first step. However, we'll continue to evolve here. We have to evolve. We'll have to touch a lot of processes. We cannot just look at components and hardware numbers, but we have to dig deeper into the software levels. Yes, quite clearly a great vision which will not be achieved in one step. It'll take several steps to get there. Question that came in just now. How do you handle a possible failure of ICAS? Yes, we'll have redundancy mechanisms fitted, installed, in particular when it comes to driver assist systems. That will become very important. We'll have redundancy ICAS computers there, which have the same functionality. Redundancy strategies and concepts. This is something which is in the concept phase. What it will look like in the end, I couldn't tell you right now. Okay, so there is something that's still left to be developed. Question here at the front. Yes, interesting tightrope walk. Customer wants everything of all sortable from all possible vendors, but okay, security is a matter. Well, we'll have to see how it's going to be received. Matthias Traub from BMW. Yesterday had a similar thought, and for me the question would go with respect to in-car or what in-car application server, that was the name. How is it scalable? Is it across several platforms? Is it just one platform with respect to series or series models? We have to take a look at the cost as well. What are your ideas here? Are you talking about hardware? Yes, correct. Well, we'll have several of these ICAS computers, definitely more than one. What the hardware below it will look like, whether it'll be the same across the board, I can't really say at the moment, but that could be one option. Okay, that fits. And more I'm not allowed to say. Well, okay, some of the subjects are not suitable to be made public yet. Nevertheless, Dr. Wille, you gave us some very interesting and deep insights into your new developments. Thank you very much.